say we want to take the derivative of, say, 5x squared. Of 5x squared, we're going to get 10x. If we take the derivative of, even if we have, say, 5x plus 3, we're still going to get 5 to 10x. If we take the derivative of 5x squared minus pi, we're still going to get 10x. Because the derivative of a constant, and a constant is like pi, is like 3 or any number like that, it's always 0. The derivative of any constant is always 0. So in this case, you notice that with these different ideas that we have, all the derivatives were the same. All the derivatives were actually saying 10x. What if we take the 10x and we want to ask ourselves, what was it before it became 10x, right? So if we want, we would have various responses. If we take a look, like it could have been this, it could have been this, it could have been this. And what we use to deal with this, right? If we want to go backwards, it is called our antiderivative, right? So it's antiderivative. So basically, we want to know what is the antiderivative. So if we're supposed to go backwards, how would we sort this out, right? So basically, this is actually coming from 5x squared. And there is some constant that we don't know. So we represent that by using C. Because while you take the derivative of a constant, it's going to become 0. So when we have the derivative here, all right, or here, and we want to know where it's coming from, we want to bear in mind that some number, some idea was actually thrown away or became 0 while it was going through the process. So we are representing that. This idea, right, this idea though, this antiderivative is what we call the integral, right? We call this the integral. So instead of probably writing all of this in Word, there's a symbol for integral, and that symbol looks like that. So this is the indefinite integral, right? So basically, this would have been saying, now let us say we want to find the integral of 10x dx, right? We want to find the integral of 10x dx. So this is the indefinite integral of 10x dx. So basically, we're asking ourselves, where did this come from? All right, so the idea of the integral is simply this. What we're going to do is that we're going to add 1 to the power, right? So this is 10 to the 1. We're going to add 1 more to it, right? So definitely we're going to have 10 to the 1 plus 1. And then we're going to divide by that new power, which is 2. And then we would have taken into consideration that some constant would have been lost. When you think back where we were, you would have seen that it could have been any one of these, so we wouldn't know. So we're going to give account for some constant that was lost, we say plus C. So when you simplify this, we're actually getting this. This 2 will go into the 10 5 times. And then we're looking at x to the 1 plus 1 more, that is x squared plus C. So this is actually taking us back to the beginning, right? And let us say, this is basically saying that, let us say this was a function. This is basically saying y is equal to 5x squared plus C. We are not sure what this is. As you could see, it could have been this, it could have been this, or it could have been a 0 here. We don't know. But this helps us to go back there. So I hope that explained a little bit about integration.